So now we've done a synthetic division and dividing dividing a polynomial by a binomial. We're going to look at the remainder theorem. And this is actually a pretty nifty little theorem. Now, remember, our ultimate goal is to find the roots. And I look at my constant, and it's a -4, and I look at my leading coefficient, and it's 2. And so I find the factors of 4. We kind of ignore the negative sign. And I find the factors of 2, we kind of ignore the positive sign, and it becomes plus or minus, and it's going to be the constant over the leading coefficient. And when we do that, we get these values, which are actually not that bad, because take a look at this. Plus or minus 1 is going to actually be the same as plus or minus 2 over 2. And plus or minus 2 over 1 is really the same as plus or minus 4 over 2. Now, I haven't actually done this question before in advance, so I'm just going to pick some values. I'm going to say, what if the solution is a positive 2? Now, once again, this might work, it might not. I'm not terribly interested in whether or not it's going to work. But if the solution is 2, that means that one of the factors would be x minus 2, because x minus 2 would then equal 0. So here's what I'm going to do. I'm going to divide using synthetic division because I know my solution should be 2. Well, I want my solution to be 2. And I put down the coefficients and the constant. And I draw my little reverse division box, if you will. Put down the 2. Draw my other line. And I always bring down my 2. And I say 2 times 2 is 4. And I bring that up. And now I add. -3 plus 4 is a 1. 2 times 1 is 2. 4 plus 2 is 6. 2 times 6 is 12, and I put this 12 here. And that gives me a remainder of 8. Now, we talked about remainders before in other videos, but here's what the remainder theorem actually means. If I have f of 2, I would end up with 2 times 2 cubed minus 3 times 2 squared plus 4 times 2 minus 4, which would be, that's going to be 2 cubed is 8 times 2 is 16, minus, that's going to be 4 times 3 is 12, plus 8 minus 4, 16 minus 12 is 4, minus 4 is 0, plus 8 is 8. Well, if you look, we just found that using the remainder theorem. What we also know is that if you divide this by x minus 2, you'd be left with 2x squared plus x plus 6 with a remainder of 8 out of x minus 2. So clearly our x minus 2 did not work. Our solution was not positive 2. I'm going to try this one more time. Let's say it was, well, let's say it was a -2. And another point about the remainder theorem is this should make sense if you think about it logically, because if there was no remainder, that would mean that this would equal 0, which is one of the solutions. So, once again, I'm going to bring this down. I'm going to bring down my 2. 2 times a -2 is -4. That gives me a -7. That gives me a positive 14, which gives me an 18 when I add them. That gives me a -36. That gives me a -40. So here's my remainder. And so f of -2, and I'm not going to do all the work. I just know it has to equal -40. So these two don't yield any solutions. Doesn't mean they're invaluable, because if we're going to graph this, it'd be kind of nice to know that information beforehand. So let's see if we can find any more solutions. I'm going to give this maybe 2 more tries. I'm just going to practice a little synthetic division and give it 2 more tries, and let's see. Let's try a positive 4. And when I'm trying a positive 4 as a solution, the factor is x minus 4. So once again, bring this down. 4 times 2 is 8. Negative 3 plus 8 is 5. 4 times 5 is 20. This is not looking good for me. 4 plus 20 is 24. This gives me 4 times 24 is 96. This gives me a remainder of 92. So f of 4 equals 92. And that's obviously not even close to what I want. So I'm going to try one more time. And no matter what happens, I'm going to be content with my values. I'm going to let it be a negative 4 this time. So I'm going to say x equals negative 4. Therefore, the factor would be x plus 4. Negative 4 times 2 is a negative 8. That gives me a negative 11. This will give me a positive 44, which gives me a positive 48. And then negative 4 times 48 gives me, let's say, negative 192. And this will give me negative 196, which is my remainder. So f of negative 4 equals negative 196. So that wasn't really close either. So these guys, oops, excuse me, I just had a technical difficulty. These guys are not going to be any of my solutions at all. So I could continue on and try, but I think you kind of get my point. That's how the remainder theorem works.